We'll be talking about climate change and the physics behind it, okay? Also some factors that impact climate change. And then we'll have a discussion at the end of class about climate change around the world and also in Wisconsin. A lot of times we hear about how climate change affects regions like the Arctic, but in fact we are seeing effects of climate change here in Wisconsin already. Okay. I have to get used to a computer that's not my own. I'll hear others talk about climate change. There's a conflation, a confusion between the terms weather and climate. So let's just get it clear before we get started today. Weather is what we experience every day. So we go outside, we say, oh, it's like a little cloudy today, the temperature is kind of warm, it's going to be in the 50s. That's what we're experiencing right now today. That's the weather. Climate, on the other hand, is the average weather in a certain location over a period of time. So that's, for example, like saying in Wisconsin in the winter, a lot of times it's cold and it's snowy. That's the average weather, the weather that we can expect in a certain region during a certain period of time. So then, now that we know what weather is versus what climate is, let's talk a little bit about climate change. If climate is the average weather in over a period of time, then climate change is the change in the average weather over a period of time. So we can see in this image, or I guess it's a GIF down here, this is looking at the average temperature, which is a way that we can measure weather, over a period of about 140 years. So it starts in the late 1800s, pretty close to when humans started to have the Industrial Revolution, a lot more pollution happening on Earth at that time. But in the early 1800s, when this restarts, you can see that it's much bluer. It's mostly blue all over the map, but then as we get closer and closer to present day, we see a lot more red on there. That's telling us that the temperature is increasing. Blue is cold, red is hot. Temperature, that's that red color. And you also might notice here that the Arctic region has the greatest change in increase in temperature. So in the Arctic regions, we're seeing a significant increase in the temperatures over time. Okay. So what actually causes climate change? You might hear sometimes that people say climate change is natural. Some of it is. Some of it might happen naturally, like for example when volcanoes erupt, that can increase the amount of carbon dioxide in the atmosphere. But most of the time, the extra carbon dioxide in our atmosphere is caused by what humans are doing. So for example, pollution from vehicles or manufacturing. Farming practices actually contribute a substantial amount of greenhouse gases, not just carbon dioxide, but methane into the atmosphere. And also cutting down trees, deforestation, taking away those sources that absorb carbon dioxide actually significantly, or is this the first time?
First time.
First time? Okay, maybe a couple people have. Well, let's talk a lot about what's albedo. So just in a really physical sense, albedo is how much light is reflected by a particular surface. When you learn about planets and things like that, you'll hear this term albedo tossed around a lot, but it's also really important when talking about surfaces. Those are the surfaces that reflect a lot of light. Low albedo surfaces are surfaces that reflect only a little light, okay? So if the light isn't being reflected, it's actually being absorbed into the material. And then do the same thing again for the white foam and record that in your table. You'll probably find that the white foam and the black foam have similar starting temperatures, yeah? Okay. Yeah, that's all good. Okay. So before we get started with the actual activity, on the front of your paper, there's an area for you to write down your predictions, okay? So what I want you all to do is to work at it as a group and figure out what your predictions are for this activity. There's questions on there that you'll have to answer, okay? So first predictions, second start activity, and then we'll come together as a class and discuss, okay?
Yeah, because black absorbs heat, right? Yeah. Black will be hotter. So what factor would impact the heat? Right?
What factor will impact the club
There you go. Okay.
Let's get some predictions.
Did we answer all the questions, or did we answer?
I think those are the predictions, yeah. For all the questions, yeah. You guys supposed to have that light on, or are we predicting instead of actually experimenting?
Okay, I'm gonna start the timer.
There you go. Here's a tip. Now you'll be done in 5 minutes instead of 10. Do both at the same time.
Oh, I didn't know that.
I'm not a
I didn't know.
Okay?
What do you think?
Try to measure like right in the middle where the light is.
More temperature, more light than the other one.
Oh yeah? You have any experience with that?
Yeah.
Really? How so?
For example, like in the summertime when it's really sunny.
Oh, it feels different from when you wear a black shirt to a white shirt? Makes sense. Makes sense. I like this. I love that. Past experience
Any other
coming into play.
Do we have any other?
Okay? Through 5 minutes.
Wait.
How's it going over here? Good? What time are you at? Oh yeah, cool.
Tell me what to do.
77.9.
It's going over here.
80.
Did you guys get for your first temperatures?
Yeah.
Nice.
That's 80.
So we just received
Yeah, either group. I was pointing to the back one, but you guys can go as well.
Yeah, read the predictions.
Did you predict that the white foam or the black foam would be hotter?
the black one.
The black one?
That's common sense.
Yeah. Why do you think it's common sense?
Because, like, I mean, it's common sense for me because I've been hearing it a lot. But, I mean, it's just common sense that black is ignored more than white.
Can you think of an example in your life where you might have experienced that before?
Wearing all white and wearing all black in 100-degree weather, I was more hot in black than I was in all white.
100%. That's right. So when you're outside in the summertime, are you more likely to want to wear light colored clothes or dark colored clothes? Probably light colored, right? And now we can kind of see the physical mechanism for why white clothes are reflecting more of that light, whereas black clothes or dark clothes are absorbing more of that light and making us hotter. So we saw that exact same thing happening with this activity today. So who had a temperature for their white foam over 80 degrees as their hottest temperature? Did anybody's get over 80? Okay, and did anybody's go over 90? For the white foam? Okay, so like between 80 and 90 are our maximum temperature for the white foam. How about for the black foam? Did anybody's black foam get over 90?
Yes.
Yeah? How about over 100? Over 100? What was your temperature?
103.7.
103.7. Did anybody get higher than 103.7? No, that's hot, right? So we can see that the maximum temperature of the black foam is much higher than the maximum temperature of the white foam. The temperatures are both increasing, but the black foam increases more. Okay. So now, this is really the crux question of it all. Which foam has the higher albedo? The black foam or the white foam? You can go ahead and shout it out.
White.
Black foam has a higher albedo.
The white one.
Yeah, now I hear some confused white, maybe? So remember, albedo is how much light is reflected by a surface. So if we're reflecting a lot of light, what's going to happen to our temperature? Is it going to be high or low? It's going to be lower. So high albedo means reflecting a lot of light and having a lower temperature over time. So which foam has the higher albedo? White, yeah. See, it's almost like backwards thinking a little bit. We're thinking about how much light is reflected here, not how much light is being absorbed. So we know that the white foam has a higher albedo because it's reflecting more light. It's not absorbing as much light as the black foam. Okay. little bit about how this concept, which we just measured, we can see that different surfaces have different albedos, and that means that they have different temperatures when they're exposed to light sources or heat over time. So how do you all think that a changing albedo might impact Earth's climate? Does anybody want to give it a shot? Okay, so we can talk a little bit about this. We know that there are different surfaces on Earth, like you all saw on the discussion questions, and different surfaces have different albedos to them. Is that right?
Yes.
And if we change the albedo of a surface, so let's say we decrease the albedo, what's going to happen to the temperature of that surface? Is it going to increase or is it going to decrease? Increase, exactly. So we change the albedo, we decrease it, the temperature of that surface is going to go up. So what areas on Earth can you think about that might have a changing albedo? Snow and ice in the North Pole, that's right. So we see in these areas that already have really high albedo, when they melt, right, because when you heat up ice and snow, it melts into water. Who can remember what the albedo of water is? It should be written on your sheet. You should see like seawater, so like 0.06 or something like that. Yeah, it's a really low number. And then what's the albedo of ice and snow? Is it really high? Is it like 0.7 or something like that? I don't know off the top of my head. Right, so we're decreasing the albedo by a factor of 10. That is going to be a huge increase in the temperature in those regions that once had a really high albedo and now the albedo is super low. So we see that impact in the Arctic regions in particular because they are the regions that are changing their albedo the most. And that's why we see climate change impacting the Arctic regions the most. But like I was saying in the beginning of our discussion, we know that this is happening in the Arctic. We're measuring it, we're seeing it. But how do you think this change impacts other regions on Earth, like Wisconsin, for example? Has anybody noticed any climate change impacts in their community here?
I know, it was kind of weird too. Last week it was like 80, now it's back to that.
Yeah, it was really hot and then it was like wintertime again, right? That was kind of unexpected. So changing weather patterns is a really common side effect of climate change. When we impact how the air moves on Earth by disrupting what's happening in the Arctic regions, have you ever heard of the polar vortex before? You might have heard about it around like winter or like New Year's time when there was a polar vortex that dipped down into Wisconsin. It was like negative 40 degrees outside and it was horrible.
That's when we get off of school.
Yeah,
Cold
you
days.
probably
The cold
didn't-
days.
Yeah, it's really cold. So when we have this region in the Arctic called the polar vortex, when it's destabilized by increasing temperatures, that polar vortex can dip down into Wisconsin and cause really cold spells in areas where it's not normally negative 40 degrees outside. We also see this with the jet stream. So the jet stream is kept stabilized by having really cold temperatures in the Arctic region and really warm temperatures in the mid-latitudes. And when you change those temperatures, when there's a smaller temperature differential and the difference between those two regions and temperature is smaller, those regions, the jet stream gets really destabilized and starts producing more significant and severe weather events. So we see a lot more flooding, we see a lot more thunderstorms that are severe that could lead to tornadoes. So even though those things happen in the Midwest, they're happening more because we're destabilizing what the weather patterns are actually experiencing. Okay. Increase albedo, you increase the amount of light absorbed, you increase the temperature. And then this process will continue. This is what we call a positive feedback loop. This is going to continue until ultimately there's no more ice anymore. The ice is going to melt because it's too significant of a temperature increase. There's no more ice on Earth anymore. I mean, you could have a freezer, right? But no more natural ice. Okay. Do you all have any questions about that? No? Okay. So we already talked a little bit about how climate change impacts Wisconsin. We talked about severe weather increasing, the amount of flooding increasing across the state. Does anybody else have any other examples of how climate change has impacted Wisconsin, or can you think of any examples?
Sometimes the roads, what's that? That stuff. Yeah. It's like sticky.
I'm not sure I know what you mean.
You're talking about the like black tar asphalt that fills in cracks on roads?
Yes, instead of actually fixing the roads.
It's so warm that it's making it a little sticky and tacky.
Oh yeah, I mean that could definitely make a difference. You might see too with more like severe weather events, more snow. There has to be more snow plows since before we were born. This is normal to us, but it's not normal, if that makes sense. So even though we're seeing like this kind of crazy weather patterns changing, this isn't what our climate is supposed to be like. And we have the evidence of data being measured over the past 150 years to show that this isn't what we should be expecting for our weather. It feels normal, but it's not normal, right? Because you guys don't know anything different. I don't know anything different. So one thing that's really important that we like to talk about with climate change in Wisconsin, there's actually a ton of lakes in Wisconsin. Not just like Lake Michigan and then the 4 lakes in Madison, but there are thousands and thousands of lakes in Wisconsin that are impacted by climate change. So one thing that's been measured, I'm sure they're doing it for Lake Michigan, I only know the data for one of the lakes in Madison. They've been measuring how much ice is on lakes over time over the past like 30 years. And what they've actually found is in Madison, there's 30 less days of ice on one of our biggest lakes there. And that has huge impacts for the species that live in there, for farmers, as well as many other things. So ice on lakes is very important in the wintertime because it really regulates a lot of the lake's properties, including temperature, oxygen levels, the water level, so you can see if things are being flooded or not.